This is Ed Robinson of Kensington College, continuing our lessons on C++. We'll look now at classes, which is really object-oriented programming. We're departing from C. C doesn't contain any object-oriented aspects. C is a subset of C++, and so this is C doesn't have classes. Well, let's take a look at a class in C++. First of all, we use the class keyword, and we have opening and closing braces. We also have a semicolon, or don't forget to put that semicolon at the end. What we've got here is data, in this case an integer. We've got two functions which access that data. So that's what a class is. A class will contain data and functions which access that data. This looks fairly much like a structure actually, so we actually could have a structure whereby we, as you've seen, we do have data within a structure, but you can indeed put functions inside a structure, but you wouldn't necessarily do that. Notice that this data is private. Now what that means is the data is not accessible directly from outside. The functions are made public and they are accessible from outside. So what we tend to do is to use these functions to access this data. We say therefore that this data is encapsulated. Now you probably don't see the point of any of this at the moment, so I'll really have to show you an example of how we might use it, how we might compile this class and then use it elsewhere and so on. That's the idea of object-oriented programming, whereas this will be the actual object which we are going to compile and use somewhere else. When we have these functions inside a class, they're generally referred to as methods, members. Yes, functions are referred to as members, member functions perhaps sometimes. A class can be regarded as a template for creating objects. So how will we do that? Well, we can introduce this code. What does this do? This creates an object of this type part, and this is just a name that I've made up. We then call the method, the member functions, upon the object. So this dot operator is important. You see, if we use a full stop, and that should show us the should call that particular and set the data. In this case we are accessing data, so here we are initializing data and here we are accessing the data. I'll show you what I mean if we single step. So if I run the program, well, let me just run it first to make sure everything's working. So I've built and run at the same step, and it just gives the output of 4. So you've set the value of I equal to 4, and then you've retrieved the value of 4. So let me just try to single step that. If I put a breakpoint here and I run my code down to that breakpoint, now you can see it's gone past. Well, I think I better show you from there. I'll just start that again and put my breakpoint a bit further up and then run that. Now you can, let's just see what happens as we press F11 to single step. So if I F11, then it's gone up. We didn't see much happening there, but it's gone and produced an object, and there's the object there. If you go and view that in the locals window, you'll see this object P1 with an element I. At the moment that element I has not been initialized, so it's got some sort of random number. So let me just single step. Now if you watch carefully what happens here, if I single step, it goes off and calls this function here, this member function. So you'll notice that the value of 4 has been passed to j, and then you see I is the internal data, if you like. So we have set I equal to the j that's been passed. So I at the moment will take on the value of 4. So we can exit from our function, and now we will talk about the get data. Well, if I now press F11 once again, it goes off to this function here. And get data, it simply comes down and returns the value of I. So it sends the value of I back here. I better be careful to do. Now if you look at the, you can see there that P1 indeed has got the value of 4. Now I better do an F10 here to avoid that cout code, and then I'll do that again, and it runs the program and produces the output of 4. Take a look. Well, I'll just comment out those two access functions, and I will try something. I'm going to try this p1 dot I. Basically, it's giving me an error. Why? Because I is not accessible. Why not? Because we have specified it as private. Now you might not see the point of doing this, but I'll show you later, as I say, when I compile it and tuck it away into a library. So this simply does not work. If this were a structure, then you know very well that it would work. That's how you access data, public data, within a structure. But for some reason we have decided to make the data private, and that means you cannot access it directly. So we'll actually get rid of that. And the way we do access the data is using functions. Now these functions are made public. Now that means that these functions have got access to the class, rather like the old Trojan horse. You may recall the story of the Trojan horse, that the horse was given to the city of Troy. They took it inside, and then the soldiers jumped out and took control of the city. I rather liken that to the public functions that we've got. These are the Trojan horses which are inside the class, which allows them to get access to the data inside the class. Generally speaking, how do you use one program's code inside another? Well, you've just been seeing what I've been doing. I've been cutting and pasting code and then running the program. So we're cutting and pasting pure plain text source code from one file to another, and then running it. But there is another very important way in which we can utilize the code from one program inside another, and that's what classes are all about. That's what objects are all about. What we basically do is compile just this part of the program, put that into what we call a library. Now that's in an executable form, and I'm going to show you exactly what that looks like in a moment. That's in an executable form. Then you make a completely separate program, and then so this, you won't see this code here. You make just this program here with using and referring to the P1 objects that we created, which indeed will be in a library. So that's the important thing, that we are introducing code, but we first of all compile this code, make it into zeros and ones basically, and then in another program we can utilize the code. Now I'm going to show you roughly how we do that. So let's pretend that this is a library I'm producing. I'll basically won't have any of that for the moment, and what I'll do is build it, and that will compile it. Well, it's a bit more detailed than that. It can be a bit tricky actually, but that's the general idea. We're going to just build this part of the program and make it into a library. Well, that's essentially what I've done here. I've produced this library by building this code here. Now I want to go and take a look at that. So I'll just copy that path there to the library file, and then I'll try and open it from here. So I'll just open a file. This is all a bit smokes and mirrors, I must admit, because there's quite a bit of things that I've left out. But if I just take a look in there in that folder for there it is there, and I'm going to open it in a special manner. I'm going to open it with the binary editor here, and then click OK, and there it is. Now it doesn't mean much, does it? But this is all our hexadecimal code. which represents the compiled version of my class. So just to reiterate, there's the compiled code. The compiled code of essentially that. We've compiled that into zeros and ones. And indeed hexadecimal, if we take a look at hexadecimal, for example, that's 2-1 in hexadecimal, which is 2 16s plus 1 is 32, and plus 1 is 33. So that represents the decimal number 33. So hexadecimal is just a shorthand way of writing binary numbers, as a matter of fact, and which speaks to the microprocessor directly. So this is getting down to ground level, if you like. Okay, so I'm going to close that project completely. And I'm going to now take a look at building another project which will utilize that project. So I'll not make another console application, and I'll introduce this code here. Now you'll notice that this code is making reference to my object, which is created by means of the class, and we call the actual members of the upon the object. But you'll notice I haven't actually defined my class anywhere. You will notice that I've used this as well. I'll explain all this a bit later, but essentially this code is using the library that I've created. Now I do remember it's important to note that this library is in compiled form, and so we are introducing that. Now in order to use the compiled form, we have to set a reference to the library. Now in order to do that, I can go to the properties of this project and take a look, looking at the linker properties, and you can see there that I've made a reference to the folder in which the library exists, and also I've specified what that actual library is. Now all this is a little bit complex, but I'm brushing over this, of course. We could do this in more detail later. Indeed we will. But for the moment, that's what we're doing. We're just setting here, we're setting a reference to a compiled bit of program. Then I can simply build my own project here, build the solution, and no errors recorded, and then I can simply run it, and you can see that it's worked. It's produced the output of 4 as previously. So once again, let me just emphasize what I've got here. I've got my own source code file, which is a completely separate project to the library, and it calls upon the library that we made in a previous project, and we know where it is, so we can set references to it. But when we run it, we don't need to include our class in here, because that's all part of the library. So we can simply create our objects as if it were part of our project. So that's the general idea of object-oriented programming. You notice here this thing P1 is an object. It's an instance of part, but it's also an object. An object is something which is compiled and we utilize within our own project.